It's tough out there, right? Trying to stay on top of everything happening in machine learning feels like there's a new breakthrough every other day. And honestly, for anyone trying to keep pace, it could be completely overwhelming.
Yeah, definitely. That's kind of why we do this, though, right? To try and help folks cut through the noise and really zero in on what matters. And today, well, what matters is causality, or more specifically, how to get large language models to think more like, well, humans do about cause and effect.
And to do that, we're going to be taking a deep dive into a recent survey paper, one that does a really nice job of bringing all the latest thinking together in one place.
Sort of like your one-stop shop for understanding why this is such a big deal, what approaches researchers are taking, and what the future might hold for LLMs with a deeper understanding of causality.
And, it really is a big deal because as powerful as LLMs are, their ability to grasp that whole why thing, the underlying cause and effect, that's still a major hurdle. And this has real-world consequences. Think healthcare, economics, any field where mistaking correlation for causation can lead to some pretty bad outcomes.
Absolutely.
So let's get right to it. The paper is titled, A Survey on Enhancing Causal Reasoning Ability of Large Language Models. It's authored by Xinli, Zhuokai, Shoujin Wang, Kunyu, and Fang Chen, all from the University of Technology, Sydney.
And their goal, to provide a comprehensive overview of, really, the state of research aimed at making LLMs better at understanding cause and effect.
Which is super valuable because, as the authors point out, even with all the work being done, there really hasn't been a unified review that pulls everything together.
Right, like mapping out the core challenges, the progress that's been made, where things are headed. This survey, it's filling that gap.
So, okay, first things first. Why is it so important for LLMs to think causally, so to speak? The paper digs into a few key reasons. The first, and maybe most fundamental, is that LLMs, they're primarily learning patterns from the data, right? Correlations. Especially with the whole transformer architecture, they excel at recognizing relationships between words based on how close they appear together, that kind of thing. But correlation doesn't necessarily mean causation.
Right. They can be brilliant at spotting patterns, but they can sometimes mistake those patterns for actual causal relationships. It's like, imagine learning to cook, but only by reading recipes.
Oh, okay, yeah.
You might be able to follow instructions, get a decent meal out of it, but you don't really understand the why behind what you're doing.
Right. Like why certain ingredients work together, or why certain techniques matter.
Exactly.
And this actually brings up another big issue, the black box problem. Often, we don't really know how LLMs arrive at their answers.
Yeah. It can be pretty opaque.
Which makes it hard to understand the logic, right? Or even to trust their outputs, especially in sensitive areas. But the paper argues that if we boost their causal reasoning abilities, we can get a bit more transparency.
Right, because if we can trace the causal relationships that an LLM is using, it becomes a lot easier to understand why it generated a particular response.
Which then makes it easier to catch and correct errors, maybe even prevent harmful outputs.
Yeah, it's like having a window into the thought process, which is huge for building trust, especially in fields like, medicine or finance, where the stakes are high.
Absolutely. The survey also highlights the fact that LLMs are increasingly being used for tasks that go beyond simple question answering. We're talking about multi-step reasoning, solving complex problems, things like that. And in those scenarios, simply relying on pattern matching, well, it often falls short.
Yeah.
Real causal understanding, that's often the missing piece for them to truly excel.
It is. Think about a complex problem, maybe in economics, where you're trying to predict the impact of a new policy. An LLM that just sees correlations might pick up on historical trends, but an LLM that grasps causality, it could actually simulate the consequences of the policy change and provide a more accurate prediction.
Right, a more nuanced understanding.
Exactly.
And finally, the paper makes a direct link between improved causal reasoning and better decision-making. Because the fact is, the data sets used to train LLMs, they're often incomplete when it comes to causal relationships. So if an LLM doesn't truly understand cause and effect, its ability to predict outcomes or make good decisions is going to be limited.
Right. It's like trying to navigate a maze without knowing which paths are dead ends.
Oh, I see.
But if they can simulate consequences through causal reasoning, then they can make more informed decisions, especially when it comes to predicting potential outcomes.
Gotcha. Okay, so to put the survey into context, the authors do a nice job of explaining how their work fits into the broader research landscape.
Yeah. They point out that other surveys might focus on LLM's general reasoning abilities, maybe on integrating them with external tools for causal stuff, or even just using LLMs as tools to solve causal tasks without necessarily improving their own understanding of causality.
Right. It's not just about using LLMs for causal analysis.
No, it's about making the LLMs themselves better at understanding cause and effect from the inside out. And importantly, they introduce a new way to categorize all the research approaches in this area, which is really helpful.
And that leads us into the core challenges, the things that are really making this such a tough nut to crack. The paper identifies 3 main hurdles. The first is the sheer difficulty of constructing effective prompts.
Yeah.
Even with the same task, subtle differences in how you phrase the prompt can lead to drastically different outcomes from the LLM.
Right. It can be really sensitive.
It's like we're trying to speak the language of causality to a system that's primarily fluent in correlation.
Exactly. And that leads to a lot of fragile and inconsistent results. The paper goes through different prompting techniques that have been developed, things like chain of thought prompting, program of thoughts, React, all trying to guide the LLM's thinking in the right direction. And it also highlights a newer one called causal chain of prompting, which seems to be showing some real promise in actual causal reasoning tasks.
Interesting. The second challenge that the paper talks about is that LLM knowledge, by its nature, can become outdated pretty quickly. That massive data set it's trained on, it's like a snapshot in time. But as new research comes out, things change in the world, the LLM's knowledge can become stale.
Yeah, it's a big problem, especially in fast-moving fields where having accurate, up-to-date knowledge is critical. And domain-specific knowledge and, real-time facts, they're particularly vulnerable to this decay.
So how do we address that?
Well, the paper talks about a couple of promising approaches. One is retrieval augmented generation, RG, which lets the LLM pull in information from outside sources, like real-time searches, when it's generating a response.
Oh, okay. So it can stay more current.
Exactly. And then there's knowledge editing, which is about actually updating the LLM's internal parameters with new information.
I see. Okay, that makes sense. And the third challenge the survey dives into is this thing called causal hallucination. Which basically means the LLM generates outputs that sound plausible, but they're not actually consistent with real-world causal relationships.
Yeah, it's like it's telling a convincing story, but the plot points don't line up with reality. And obviously that's a big problem for tasks that need accurate causal reasoning.
Totally. So to combat that, the paper talks about integrating knowledge graphs. These are structured ways of representing entities and their relationships, which can help keep the LLM grounded in actual facts.
Right. It's like giving the LLM a reference guide to check its work against.
Exactly. And then there are fine-tuning methods like freeze tuning, adapter tuning, and P-star tuning, which involve selectively updating parts of the LLM to reduce these hallucinations.
Right.
So given all these challenges, what progress have researchers actually made? And this is where that new categorization the survey introduces really comes in handy. They divide the existing methods into 2 main groups, domain knowledge-driven and model-driven. Let's start with domain knowledge-driven, which, as the name suggests, focuses on incorporating real-time, domain-specific knowledge into the LLM's reasoning process.
Yeah, because that pre-trained knowledge, it's often not enough for robust causal reasoning in specialized areas. And then the paper breaks this category down even further.
Right. So the first subcategory is about leveraging domain experts. Makes sense, right?
Yeah.
Who better to understand the complex causal relationships in a specific field than the people who've dedicated their lives to it?
Absolutely.
The paper mentions things like the Medic Copilot, which uses expert input to prevent medication errors. And there's research on using expert validation in the process of creating those causal graphs we talked about earlier.
Yeah, and the benefit is pretty clear. Expert knowledge helps LLMs identify the key causal links, make better inferences, and stay ethically aligned, which is huge in sensitive fields. But the paper also acknowledges that this approach can be expensive, time-consuming, and potentially even introduce bias.
Right. Another subcategory under domain knowledge-driven is contextual knowledge. The idea here is to give the LLM more background information about the specific situation it's dealing with.
Right. Context is everything.
Exactly. And the paper mentions a few ways to do this, like using temporal causality from real-world events, incorporating pairwise causal knowledge, even feeding in whole knowledge graphs.
Yeah. By giving the LLM more context, it can understand the nuances of a situation and make better causal judgments. But processing all that extra information can slow things down, so researchers are looking into ways to make it more efficient.
The paper also talks about the importance of predefined prompts, which we touched on earlier. Good prompts are essential for guiding LLMs in the right direction.
They are. It's like giving the LLM clear instructions.
Exactly. And the paper highlights a few interesting frameworks here, like ALCM, which uses specific causal prompts, universal prompt sets that work across different tasks, and that CDP framework, all aimed at getting better causal reasoning out of LLMs. But the tricky thing with prompts is that they can be really sensitive to wording. Even small changes can lead to different outcomes.
Yeah. It's an art as much as a science, and it requires careful fine-tuning.
And speaking of fine-tuning, that's the last subcategory under domain knowledge-driven. This is where we take a pre-trained LLM and train it further on specialized data sets relevant to the task at hand.
Yeah. It's like giving the LLM a crash course in a specific domain.
Exactly. And the paper gives examples like fine-tuning LLMs to extract causal relationships from medical guidelines, even developing new LLM architectures specifically for causal reasoning. Fine-tuning can be very effective, but it can also be resource-intensive.
Yeah, it takes a lot of computing power and relies on having those high-quality data sets to begin with, which can be a challenge.
Okay, so that covers domain knowledge-driven methods. Now let's switch gears to the second main category, model-driven methods. This is all about incorporating causal structures and algorithms directly into the LLMs. And the paper breaks this down into three main classes. The first is causal graph construction.
Yeah, those diagrams that visually represent cause and effect relationships.
Exactly. And it turns out LLMs are actually pretty good at constructing these graphs from text.
They are. It's pretty amazing.
The paper goes through a bunch of different approaches, like using breadth-first search algorithms with LLMs, incorporating expert knowledge to guide the graph creation, even combining LLM inference with established structure learning algorithms. Causal graphs provide a really structured way to approach reasoning, but the challenge is that real-world causal relationships can be very complex and hard to capture accurately.
Absolutely. It's like trying to map out all the cause and effect relationships in a rainforest. There are just so many variables at play.
Oh, I see. The second class under model-driven is causal effect estimation. This is about quantifying how much of a change in an outcome is caused by a change in a particular factor.
Right. It's not just about identifying that there's a causal relationship, but understanding its strength.
Exactly. And the paper mentions methods like front door adjustment to reduce bias in these estimations. But there are limitations, especially because of the unstructured nature of data and issues like bias. The survey highlights some new frameworks that are being developed to address those limitations.
Right.
And finally, the last class under model-driven is counterfactual reasoning. This is all about what-if scenarios.
Yeah. Exploring how things might have turned out differently if certain conditions had been different.
Right. And the paper discusses some cool approaches, like combining out-of-context prompting with counterfactual transformations, and more complex frameworks that also use knowledge graphs. Counterfactual reasoning lets LLMs evaluate the impact of changes, which is crucial for understanding causality.
It is. It's like running simulations in their heads.
Exactly. But doing that can be computationally expensive and potentially impact performance.
Yeah, there are always trade-offs.
So to know how well all of this is actually working, we need good benchmarks and evaluation metrics, right?
Yeah.
The survey dedicates a whole section to this.
Absolutely. It's like setting up a standardized test for causal reasoning.
Exactly. They categorize benchmarks into a few areas: reasoning with tabular data, reasoning about graph structures, and reasoning in natural language understanding. Each one tests a different aspect of causal reasoning ability. And when it comes to metrics, the paper introduces a few key ones, like structural Hamming distance, structural intervention distance, Caesar, and causal score.
Right. Each one measures a different aspect of how well the LLM is doing in terms of causal reasoning.
Okay, so looking ahead, the survey lays out some exciting directions for future research. One is improving multimodal causal reasoning. Real-world data isn't just text, it's images, videos, audio. And with the rise of multimodal LLMs, understanding causality across all those different modalities is going to be huge.
Absolutely. It's like teaching LLMs to see the cause and effect in a video, not just read about it in text.
Exactly. Another big direction is developing new memory mechanisms within LLMs. Current LLMs can struggle with long-range reasoning and those causal hallucinations we talked about.
Right. It's like their short-term memory isn't always great.
Exactly. So building more robust memory capabilities could help them hold on to relevant information and reason more effectively over longer stretches of time.
Right. And the paper actually mentions a layered memory mechanism that's been used in financial decision-making as an example.
Interesting. The survey also talks about the need for new self-learning mechanisms.
Mm-hmm.
Unlike us, LLMs depend heavily on their pre-trained knowledge, which we know can go out of date.
Yeah, it's like they're stuck with what they learned in school, so to speak.
Exactly. But if they could continuously learn and update their understanding of causality over time, that would be a game changer. The paper mentions this point in the unknown concept as a possible direction.
That's a really intriguing idea. It's about encouraging LLMs to actively seek out new information that challenges their existing understanding of causality.
And of course, there's the crucial issue of ethical alignment. As LLMs become more involved in tasks that require causal reasoning, especially in sensitive areas, we have to make sure their outputs align with human values and ethical principles.
Absolutely. It's not just about making them smart, it's about making them responsible.
Exactly.
Yeah.
And the paper points to ongoing work on things like detecting toxic content as a step in that direction. Finally, the survey emphasizes the ongoing need for unified evaluation metrics and better training data sets.
Yeah. It's hard to compare different approaches if everyone's using different yardsticks.
Right. And having good quality diverse data is essential for LLMs to generalize their causal reasoning abilities to different situations.
Absolutely.
So to sum it all up, this survey paints a really valuable picture of a rapidly evolving and incredibly important field.
It does. It highlights the challenges, the progress, and the exciting possibilities that lie ahead.
Exactly. And for those of you who want to dig deeper, the link to the full paper is down in the episode description. Now, before we wrap up, it's time for our Novel Notions segment, where we take a concept from the paper and sort of run with it.
I always enjoy this part.
Me too. So the paper talks about integrating knowledge graphs with LLMs to help with those causal hallucinations, right?
Right.
And it also discusses the need for better memory mechanisms. So what if we combined those ideas and created something called causal knowledge agents?
Causal knowledge agents, huh? That's interesting. What do you have in mind?
So instead of just passively pulling facts from a static knowledge graph, these agents would actively build and refine their own internal causal models based on their experiences.
Oh, I see. So it's not just about looking things up. It's about learning and adapting their understanding of cause and effect over time.
Exactly. Imagine an LLM tasked with optimizing traffic flow in a city. Currently, it might analyze historical data and make recommendations based on correlations. But a causal knowledge agent, it could interact with real-time data from sensors, observe the impact of its actions, like changing traffic light timings, and actually update its own causal model of the city's transportation network.
Wow, that's a pretty cool concept. So it's not just pattern recognition, it's actual causal discovery happening in a dynamic environment.
Exactly.
But that sounds incredibly complex to implement. What kind of architecture would you need for something like that?
It would definitely be challenging. Maybe a hybrid approach, combining a core LLM for language and reasoning with something like a dynamic causal Bayesian network that's constantly updating based on new input and observed outcomes. And maybe even specialized causal memory modules designed to store and retrieve those cause and effect relationships.
It's like an LLM with a built-in learning loop for causality.
Exactly.
What kind of implications do you see for a technology like that?
Well, the potential is huge. We could have AI systems making much more reliable decisions in really complex situations, everything from autonomous robots that truly understand the consequences of their actions to sophisticated financial models that can better predict and mitigate risks. But obviously the challenges are massive too. We'd have to ensure the accuracy and reliability of these self-constructed causal models, and the computational resources would be significant.
It's definitely a frontier area, but it's one worth exploring. The future of AI and causality is full of these kinds of thought-provoking possibilities.
Absolutely. And on that note, we're going to wrap up this deep dive. Until next time, keep those critical thinking caps on and keep questioning those correlations.